trust you did well on that quiz. Turn your books to page 84, if you would, please. We're going to talk about an extra concept. You notice it says level up. Okay, level up concepts aren't something I'll usually test you or quiz you on, but it's something that is going to be helpful for you to know. It's going to make your life easier in science classes in many cases, or in future math classes. I want to talk about something called significant digits. It's also sometimes called significant figures. Many of you are in the back of my physics class, and you'll hear me say over and over again, sig figs, sig figs, sig figs. Significant figures basically refers to rounding off an answer based on numbers that are given. Let me give you an example here. Let's suppose there is a rock, and you want to figure what the density of this rock happens to be. So you go over to the science lab and you ask Miss Morse if you can borrow her scale, and you put the rock on there and you measure the rock, and it comes out to 82.123 grams. Okay? Let's suppose somebody else took the same rock and they walk over to their bathroom scale, they put it on the bathroom scale, which for some reason wasn't made in the United States, and it says 82 grams. Whose scale is more detailed or more accurate, class? Miss Morse's, because it can give you 3 digits, 3 decimals. It can be down to the milligram technically then, can't it? Because that'd be the thousandths place. Okay? And then this person with the bathroom scale, 82 grams. Suppose you also wanted to measure the volume, because you wanted to figure the density. You measure the volume and somehow use technical instruments, and you find that the volume of this rock is, let's say, 42.933 cubic centimeters. And let's suppose another person with their tape measure, they kind of figure the volume of the rock, and they figure it to be 42 cubic centimeters. Who got the more detailed measurement here? Obviously, the first person, correct? Well, if you were to take out a handy-dandy calculator, which I just so happen to have, and you were to say, well, I know that density, represented by a Greek letter, we'll get into that later in science, is the mass of an object divided by its volume. So you say, okay, I'm going to take the mass, which was 82.123 grams. I'm going to divide that by the volume, 42.933. And the calculator says this, 1.9128176 and it leaves off with a 6 at the end, but the number just keeps going for a while. It's a really weird decimal. And that's how many grams per cubic centimeter the density is. And this person also takes handy-dandy calculator and takes, 82 divided by 42, and they get 1.9523809, and then it gives a 2, and the number just keeps going, grams per cubic centimeter. Well, these answers obviously differ from each other. Why? Because one person got really detailed measurements, the other person didn't get as detailed measurements, right? Well, here's what it comes down to. If I say that this is my answer, this is really detailed and exact looking, isn't it? It's more detailed and exact looking than the numbers I started with. And in science, you can't report numbers that are more detailed than the numbers you used to get them, is the idea. So what we do with significant figures is we count up how many digits are in the number that matter. And there are 1, 2, 3, 4, 5 digits that matter here, 1, 2, 3, 4, 5 digits that matter here. So in my answer, I'm allowed to use 5 digits in my answer. 1, 2, 3, 4, 5 digits. I'm gonna have to cut it off there. Does the 1 bump the 8 up, class? No, it just falls off. So we'd say that the density of this particular rock is a very detailed looking 1.9128 grams per cubic centimeter. It looks very detailed because the numbers we used are very detailed. Let's come over to the other guy. How many digits of significance do we have here? Well, I see 2 digits here and I see 2 digits here. So guess how many digits he's allowed to report? 2. Because again, this answer looks really detailed, like he did a lot of scientific work. Not so much. We're going to cut it off at 2 sig figs. What does the 5 do to the 9?
Bumps it up.
Yeah, it doesn't just fall off, it bumps it up to a 10, which means we write the 0, carry the 1, and we end up with 2.0 grams per cubic centimeter. And so his answer doesn't look nearly as detailed. Now they're pretty close, right? I mean, 1.9128, 2.0, they're pretty close to each other. But this guy shouldn't report his answer detailed like this guy, because he didn't really get detailed measurements to begin with. That's the idea behind significant digits, is your answers shouldn't be more significant or detailed than what you start with. Yes, ma'am?
What about with the ones that you start with? What if it has a different number of digits with like the grams of...
Okay, so this, again, the question is, what if it had been, 82.17 grams, but for some reason you couldn't get a really detailed measurement here? You would go with whatever number's least significant. So this has 4, this has 2. Well, you have to go with the smaller number because the 42 is kind of limiting, right? I didn't get very detailed here, so I can't get detailed in the answers. Even if this has more, that has less. So for instance, let's suppose this guy also couldn't get very detailed. Well, now he's stuck with only 2 sig figs, and he's coming in at 1.9. Does that make sense? Of course, it would have divided a little differently too, but does that make sense? All right, so here's the bigger thing that I want you just as 8th graders to get into. So we're not going to worry about actually doing a lot of the calculations and stuff like that yet. That's coming later on, mainly in science classes. But I want you to figure out how to tell what numbers are significant. Look over at page 85, and it gives you a list of what numbers are significant. And the first one is what we saw a moment ago. Anything that's not a 0 is significant, okay? So I specifically chose numbers that didn't have zeros in them. Everything's significant. So you literally just count how many digits you see. But there are times that zeros are significant and sometimes zeros are not. For instance, look at the second rule. Zeros that are in between non-zero digits are significant. For instance, in the number 309, you see that 0 in the middle. Well, the 0 matters right there because it's part of the number 309. You couldn't take that 0 out and still have the number, could you? The 0 very much matters. It's very important. So the 0 is significant. Look at the next number right below it, 30.09. Again, if you took those zeros out, the entire number changes. Does that make sense? So do those zeros matter? You betcha they do. Of course they matter. They're very significant. Look at the next rule. In numbers with a decimal point, zeros after the number, zeros to the right, it says, are significant. For instance, when I say 0.120, normally would I say I have to write that 0, class? No. But if I take the time to write the 0, there's a reason. I'm saying this isn't 12 hundredths rounded to the hundredths place. It's 120 thousandths. And I went on purpose to the thousandths place to show that detail. For instance, if I put an object on Miss Morse's scale and it says it's 7.120 grams, the fact that that's a 0 and not some other number is significant. It means it really is 7.12, right? For instance, if this were 1.72 or 7.121, that would still be kind of the same as 7.12, right? Even 7.122 would still kind of be 7.12, right? It's not that I rounded to get this 2 and I just knocked the other numbers off. No, even this digit, it really is significant. Does that make sense? So but with the presence of the decimal just helps to indicate I actually rounded to the thousandths place, or in this case the milligrams, not to the centigrams, for instance. Even if the decimal's at the end of the number for good. For instance, 1,200. For instance, if we said there's about 1,200 employees at TSYS, I don't know if there are or not, but let's just throw that number out there. You assume I probably just rounded off, or 1,200 employees, he probably just rounded off to the 100 of employees, right? What if I actually counted and there were exactly 1,200 employees? How would I show that I didn't round to 1,200? I really mean, that's exactly how many there are. By putting a decimal point here, it shows to the nearest whole employee. Just don't think about that too long, right? What's a partial employee? Anyway, to the nearest whole employee. This is really how many there are. So the presence of a decimal point and zeros that are trailing means those zeros are significant. If I didn't want them there, I wouldn't have written them. The decimal shows the significance. But there are times zeros aren't significant. For instance, if zeros begin a number. For instance, if I were to count the number of students in the classroom right now, and I were to have to report this on a standardized form, usually they give you 4 digits to fill in because some classes are massive. Our class has 8 people in it at the moment. So I would say there are 0, 0, 0, 8 people. These zeros at the beginning are really just there to fill space. Does that make sense? I'm kind of Quentin. All right, so these zeros are just there to fill space, right? They don't really matter for anything, do they? So they're not significant. There are not 4 digits that are significant. There's just 1, okay? But even if I said 0.00005, well, again, the only purpose of these zeros is to make sure the 5 winds up in the, the 10,000th place or 100,000th place, rather. It's just there to put the 5 there. These zeros don't really matter. So, basic rules. If the zeros are in the middle of the number, class, are they significant?
Yes.
Yeah. If they're at the end of the number and there's a decimal, are they significant? Yes. If they're in front of a number, are they significant?
No.
Never. And if they're at the end of a number, but there's not a decimal point in the number, then we assume we don't really, these are just to fill space, kind of like these ones, but we're not saying exactly 1,200. I just kind of estimate there's about 1,200 people. So if they're at the end of a number and there's not a decimal, they're not significant. Does that make sense? Look at the yellow box with me now. 3,200. How many non-zeros are there, class?
2.
2, right? So we know there's at least 2 sig figs. The question is whether or not the zeros are, right? We know the non-zeros are always significant. So are the zeros significant or not? Well, they're at the end of the number, right? For them to be significant, what has to be in the number with them? A decimal somewhere. Is there a decimal?
No.
So do they matter? No. So how many significant digits?
2.
2. So if then I were getting some answer, my answer couldn't have more than those 2 significant digits in it. That makes sense? So that's how I know how to round off my number. Look at the letter B. I've seen 2 zeros. The first one's in the middle. Is it significant?
Yes.
The last one's at the end. It's only going to be significant if there's a decimal. Is there a decimal?
Yes.
Yes. So is it significant?
Yes.
So notice there are 5 significant digits in that particular number. Does that make sense? All right. So let's go ahead and take a look at the next page at the 1 through 12. And let's just see which of these digits are significant, which ones aren't, and so forth. So we're focused on the underlined digit. On number 1, is the underlined digit significant, class?
Yes.
Yeah, if it's not a 0, it's gonna be significant. That's pretty easy. What about number 2? Is that significant?
Yes.
Because it's in between, right? It's in the middle of the number. Number 3, is that significant?
Yes.
Yes, it's at the end, but there is a decimal point, so that is significant. Number 4, is that 0 significant?
No.
Nope, it's before the number even starts. So all it is a placeholder. It carries no significance at all. So how many sig figs would be in number 4, class?
3.
Only 3, the 2, the 5, and the 7. Number 5, is that significant?
Yes. No.
No, it's at the end of a number, but there's not a decimal point. Number 6, is that significant?
Yes.
Yeah, it's not a 0, of course it is. Number 7, is that significant?
Yes.
Yes, because it's in the middle of the number. What about number 8, is that significant?
Yes.
Yes, it's after the number ends, but there's a decimal in there, so it's to the right, but there's a decimal, so it's significant. What about number 9?
Yes.
Same reason, right? It's to the right, but there's a decimal. What about number 10?
Yes.
Yes, because it's in between. It's in the middle of the number. What about number 11? No, it's before the number really gets going. What about number 12? No, there's not a decimal in there. Do we see how to interpret whether or not a 0 is significant? Yes, ma'am.
I'm confused about back on number 3.
Number 3, it's at the end of the number, right? But the fact that the fact that there's a decimal, so it says 0.70. Normally, if I'm my lazy self, I'm just saying 0.7, right? The fact that we took time to put that extra 0 shows we went all the way to the hundredths place. It's that specific. We didn't round to the tenths. We rounded to hundredths, and we took the time to put it, so that makes it significant. Basically, if there's a decimal anywhere in the number, and the 0's at the end, it matters. If there's not a decimal in the number and the 0's at the end, it don't matter. Make sense? All right, so I want you to go through now and do the 13 through 23 odd. 13 through 23 odd, and figure out how many digits are significant. So just writing a number down next to each of these, how many significant digits in that number? (13 to 23) just the odd. And next year when you take physical science and Miss Morse teaches you all this, you'll be like, oh, I got this already. And you'll be happy. Glenn's like, nope, I'm going to forget it all, I promise. Well, at least it won't be the first time you've seen it. How about that? Somewhere in the vast recesses of his mind, he'll be like, I remember seeing that. Sorry, I didn't mean to cut your shoulder off there.
Sure.
All right, let's see how we did. Number 13, class? 3. Number 15?
1.
Only 1. Is there a decimal?
No.
So we assume I rounded to the nearest 10, and we said it's about 70. It's a rough estimate. It's only got 1 digit of significance. What about number 17? 3. The first 2 zeros are not, but because there is a decimal, that last 0 is. Number 19?
4.
4. There is not a decimal in the number, so we just figured we round to the nearest 100-ish. Those last two digits are not significant. Number 21.
4.
4. The first two are not, but the middle 0 has to be because it's in the middle of the number. So the 1, the 0, the 8, and the 2 are all significant. And number 23.
1.
Just 1. Remember, zeros ahead of the number don't matter. They're not significant. All right, so some of us got them, some of us didn't. Anyone perfect on all 6? All right, whether or not you are, do you feel like now that we talked through them, you understand it better? Go back into the evens. 14 to 24, the even now. Let's see if we can go 6 for 6 on these. Go back and do those evens. Let's see if we can go 6 for 6. Cold. Or math is just so fun, it gives you chills. I don't know.
Sure.
All right, let's see how we did on these. And number 14, what'd you get, Danielle?
4.
4. Number 16, Michael.
2.
2. Number 18, Hayden. There's a decimal at the end.
Oh,
I didn't round to the nearest 100. That's exactly 800, so it should be 3 sig figs. Number 20, Aubrey.
2.
2. Number 22, Lexi.
1.
Obviously just the 1, right? And then number 24, Glenn. 7. And we go 6 for 6. Got them all this time. All right, how many did you miss?
5. I mean, 1.
Okay, which one?
5.
Number 24, I put 6. But it's 5.
It's 7.
What?
Okay, the 2 zeros in the middle have to be significant, right? But so does the 0 at the end, because there is a decimal in the number. Does that make sense? Yeah.
So it can be anywhere in the number.
Doesn't matter where the decimal is. If the decimal is in the number, that makes the 0 significant.
Okay.
All right? Questions on this? All right. Well, no homework this evening. Have a wonderful rest of your day. When the bell rings, you will be dismissed.